Lesson 1-2. The graph shows a function that models the value V in millions of dollars of a stock portfolio as a function of time t in months over an 18-month period. On what interval is the function increasing, or on what interval is the function decreasing? So let's take a look. What we'll do in red. Decreasing. We start here, we read the graph from left to right. We go and it gets up to a high right here, and then it decreases all the way down until it gets to right here. All right, so on the x-axis, that will be from 3 to 13. So on what interval is the function decreasing? 3 is less than t is less than 13. Next it says, on what level is the function increasing? On what level is the function increasing? Well, it starts out at 0 and it goes to 3, so 0 is less than t is less than 3, and then at 3, well, it goes down there, but here it starts going back up, and so let's see, 13 is less than t, or you could write it as t is greater than 13. Identify any maximum values. Identify some maximum. Well, right here is a maximum value, and right there is a maximum value. So maximum value, t equals 3 and t equals 18. And minimum values, well, here and here, and we're going to say t equals 0 and t equals 13. That's the minimum values. What are the function's domain and range? Well, where does it start? The domain starts here at 0 and goes all the way to 18. So the domain, I'll write it up here. Domain is 0 is less than or equal to t is less than or equal to 18. The range, that's the low right there, and the high is up there. So the range, and let's see, that looks, excuse me, 3/4 is less than or equal to V for value, and it goes up to less than or equal to 3. So there's your range. The range is from here to here. Okay. Number 4, well, let's see here. The table of values gives a probability P of n for getting all files when rolling a number cube n times. Oh. Have to go back up. The table of values gives a probability P of n for getting all files when rolling a number cube. Is P of n increasing or decreasing? Well, it starts out as 1/6. Then it goes to 136, and then at 1 over 216, 1 over 1290. I'd say it's decreasing. All right. Explain the significance of this. Well, if you were to draw a little graph here, it would look something like this. and then getting close. Oh, that's not a good drawing. And then it goes like that. It's getting closer and closer to 0. So we say P of n is getting closer to 0. What is the end behavior of P of n? As x approaches positive infinity, f of x approaches 0 from the positive side. And the significance is it gets smaller and smaller, closer and closer to 0. Number 6. I'm going to make it a little bit bigger now. Let's see here. Make it easier to see. There we go. The table shows some values of a function. On which intervals is the function average rate of change positive? Select all that apply. All right, which one's it? 0 to 1 is positive? Yeah, that goes from 50 to 75, so that's going to be positive. From 0 to 3 goes from 50 to 65, so yes, that's positive. E from 1 to 3, no, that goes from 75 to 65, so that's not it. From 0 to 2, that goes from 50 to 40, that's not positive. That would be minus 10. From 1 to 2, from 1 to 2 goes from 75 to 40, no. And F from 2 to 3, well, yeah, that goes up 25. So those are positive. Use the graph of the function f of x to identify the function's special attributes. Find the function's average rate of change over each interval. All right, so let's see here. From negative 3 to negative 2. It goes from, well, let's see here. At negative, this here, that is negative 2, 0. And this part here, I'm sorry, it's negative 3, 0. Well, I'm having a hard time writing. I think there's some drag on this. We got negative 3 to 0. And then this point here is going to be negative 2, 2. So to find the average rate of change, remember that old m equals, and then you got y2 minus y1 over x2 minus x1, the slope formula. So we got 2 minus 0, 2 minus 0 over negative 2 minus negative 3. So it's going to be 2 over 1. So the average rate of change is going to be 2. All right, let's try it from negative 2 to 1. One's right there, so that's, what is this point here? That's going to be 1, negative 4. Well, we'll use the same formula. Negative 4 minus 2 over negative 2 minus 1. So negative 4 minus negative 2 is negative 6 over negative 2 minus 1. Oh, I did that wrong. That's 1 minus negative 2. And that's going to give you 3. So m is going to equal negative 2. All right, our next one. What's our next one? From 0, which is going to be here, to 1. That's 1, negative 4. And this right here is going to be 0, negative 3. So we're going to have negative 4 minus negative 3 over 1 minus 0. That's going to give us negative 1 over 1. So m equals negative 1. So the slope of negative 1. What about from 1 to 2? 1 to 2, that's going to be 2, 0. So we're going to have 0 minus negative 4 over 2 minus 1. It's going to give us 4 over 1. So m equals 4. Now there's another way to do it too. We got negative 1 here, and to 0. 0, that's going. All right, so we've got negative 1, 0, and we got 0, negative 3. You could go 1, 2, 3, 1, so that's going to be m equals negative 3. And we'll try it numerically just to make sure. What do we got? We got negative 3 minus 0 over 0 minus negative 1. That's going to give us negative 3 over 1. So we get the same answer. All right, we're going from negative 1 to 2, and that's going to be right there. That's going to be 2, 0. 2, 0. So let's try that. We've got 0 minus 0 over 2 minus negative 1. That's 0 over 3, which is m equals 0. 0 divided by 3 is 0. Oh, I needed to go back to that. It says, on what intervals are the functions values positive? Okay, well, we got to, so A was positive, B was negative, C was negative, D was positive, that's negative, and that's 0. So A and D. On what intervals are the functions negative? Well, that's B, C, and E. So we'll put B, C, and E. And what are the zeros of the function? What are the zeros? Well, that's here. That's going to be x equals negative 3. And we got one here. X equals negative 1. And we've got one here at x equals 2. Those are the zeros. What you really need is you can use those zeros to find the equation. The following describes the United States nuclear stockpile from 1944 to 1976. Okay, from 1944 to 1958, there was a gradual increase in the number of warheads from 0 to about 5,000. So 0, and how many years is that? 58 minus 44, 8, that's 14 years. So 14 years is going to be about right in here somewhere. And so it went to 5,000. So we're going to put that point right there. Okay? So there we are. From 1958 to 1966, 66 to 58, I'm getting 8. So that, let's see here, that's 2, 6, 7, 8, that's going to be right there. There was a rapid increase in the number of warheads to a maximum of about 32,000. So let's see, that's 30, 32, we'll say 32 is about right there. Okay, we've got that. From 1966 to 1970, that's 4 years. So this will be where we're at on the x-axis now. There was a decrease in the number of warheads to about 26,000. So let's see, that's 26,000. And finally, from 1970 to 1974, there was a small increase to about 28,000. So that's going to be 4 years, and we're going to go up like this. Sketch a graph of the function. Well, let's graph it. I'm going to get my straight line tool here. Feel free to use your ruler if you'd like. And there we go. We drew the graph. Number 12. The following describes the unemployment rate in the United States from 2003 until 2013. That's a total of 10 years. In 2003, the unemployment rate was at 6.3%. So let's find that. And we'll say it's about right there. All right. The unemployment rate began to fall over the years and reached a maximum of 4.4%, a minimum of 4.4% in 2007. So that's 4 years. 4.4%. And we'll say that's about right there. A recession that began in 2007 caused the unemployment to increase over a 2-year period and reach a maximum of about 10%. So 10%, we'll say it's about right there. The unemployment rate then decreased over the next 4 years to about 7%. So that would be 10, and let's see, that's 6. 7 is about in the middle there, and we'll sketch a graph. Oh, that was it. And there we go. Number 13. The following describes the incidence of mumps in the United States. I would like for you to try this one on your own, following the pattern of the last two. Aviation. The table gives the lengths and wingspans of airplanes in the airplane's fleet. Okay. Let's take a look at it. So length, this is length is this number here. This is the length. That's the length. That's the length. That's the length. That's the length. And that's the length. And these are all widths. Okay. All right. Make a scatter plot. So each one of these are going to be each one of these. So this one here is going to be 130, comma 113. So let's find that spot. 130, and I'm assuming that's 120. Let's see. 120, and then we'll go down a little bit. We'll say that's right there. And then the next one we got is 148, 108. Let's see, 148. So that's 140, that's going to be 148, and then 108. That's maybe like right there. Okay. The next one is going to be 155, 124. So let's say 155 right in there. 124 is going to be, we'll say maybe right in there. And then we've got 178 and 147. So 160, that's probably 200. So 178 is maybe right in there. 147, we'll say, is maybe right there. Then we have 180 and 156. That's the next one. 180. So that's 200. 180 is right, maybe in the middle. 156. That's 160. So we're looking at maybe right in there. And then we have 209 and 200. 209. It's going to be right after that. And then 200. Let's see, 180. It's probably right in there. Okay. So we did that. Sketch a line of fit. So we're going to try to draw a line that goes right through, right as close as we can to all of them. And we'll say that's maybe it right there. So we did that. Now, use a line of fit to predict the wingspan of an airplane with a length of 220. So that's 220. And we're going to say that's going to be, let's see, that would be about right in here. And we're going to estimate, let's see, that's going to be 180, 200, that's 220. We'll say 205 feet. Okay? And this is just all estimation. We'll also learn how to do it with the calculator and get a much more precise number. Number 15. I would like for you to do number 15 on your own. All right? And see what we can do with it. And that's all, folks. I hope you have a wonderful day, and we will see you in class.